Okay, yeah. Hello, everyone. Welcome to the presentation, Green Health Related to Heavy Metals After Long-Term Poultry Application. I'm Frank Yin, an associate professor in the Department of Plant Sciences at the University of Tennessee. Poultry production is an important industry in Tennessee and the Mid-South. Poultry is an economical and effective source of crop nutrients. Poultry application is a good practice for enriching soil nutrients and improving soil health and crop production. Applying poultry has positive effect on soil properties, such as increasing soil aggregate stability, available water content for plant, and soil carbon and nitrogen stocks. Poultry application is commonly based on crop nitrogen requirement. However, it also contains other elements such as phosphorus, potassium, magnesium, etc. In previous studies conducted in Tennessee, soybean yield, soil carbon storage, and soil phosphorus and potassium contents were significantly increased after long-term poultry applications compared with no poultry application. However, the impact of poultry application on heavy metal accumulation in the soil and crop grains were largely unknown under Tennessee production systems. Therefore, we conducted a study to estimate heavy metal contents in soil profile and the heavy metal concentrations in corn and soybean grains based on 2 long-term field trials with and without poultry application in mid and west Tennessee. This study was conducted on the research and education centers in Minot and Spring Hill at the University of Tennessee. We used the 2 existing long-term field trials relating to cropping systems and biocovers, which were initiated in 2002. The crop systems we used for this study were continuous corn and continuous soybean. The 2 biocover systems we used were poultry application at 4.4 tons per hectare applied annually as a nitrogen source, and no poultry application at the control. These are some values about the elemental contents from the poultry samples we collected. Corn and soybean grain samples were collected at harvest in 2017. Soil samples were taken at 0 to 15, 15 to 30, 30 to 60, and 60 to 90 centimeters after corn and soybean harvest in 2017. The total and available contents of heavy metals, including arsenic, cadmium, chromium, copper, lead, and zinc, in the above soil and crop grain samples were determined. The total content of arsenic, cadmium, chromium, or lead was not increased by long-term poultry litter application. However, the total contents of copper and zinc were significantly enhanced after long-term poultry litter application. The total copper content was increased by 70% and 50% with poultry litter application compared with no poultry litter in Marlin and Spring Hill respectively. Similarly, application of poultry litter increased the total zinc content by 17% in Marlin and 11% in Spring Hill. Poultry litter application consistently increased the total copper content in the surface soil of 0 to 15 centimeters relative to no poultry litter. The total copper content was increased by 90% and 70% at Spring Hill and 110% and 70% at Marlin in surface soil under corn and soybean production respectively after long-term poultry litter application compared with no poultry litter application at the control. Applying poultry litter sometimes significantly increased total zinc content in the surface soil relative to no poultry litter. The total zinc content was increased by 24% under continuous soybean production at Spring Hill and 25% under continuous corn at Marlin in surface soil after long-term poultry litter application. In this study, poultry litter application caused copper and zinc accumulation only in the surface soil with almost no impact being observed on copper and zinc contents in deeper soil. Long-term application of poultry litter contributed to the accumulation of available copper in the surface soil. However, poultry litter application showed no impact on available copper content in deep soil. Similarly, long-term application of poultry litter frequently increased the accumulation of available zinc in the surface soil of 0 to 15 centimeters. However, poultry litter application had no impact on available zinc content in deeper soil. In order to further characterize soil contamination by heavy metals due to poultry application. Three contamination indices, including contamination factor, degree of contamination, pollution load index, were used to evaluate heavy metal contamination in the soil in this study. The contamination factor CF was used for each heavy metal. The sum of contamination factors were used for the sum of all heavy metals. The pollution loading index was used to assess the severity of soil pollution after poultry application. These are the classification criteria we used for the three contamination indices, CF, DC, and PLI in this study. For example, when the CF value was below 1, that meant no contamination. According to the classification criteria shown in the previous slide, poultry litter application significantly increased the contamination factor of copper at both locations and the contamination factor of zinc at minor only. However, all the contamination factor values were in the moderate contamination category. The degree of contamination was enhanced by poultry litter application relative to no poultry litter application at both locations, but all the degree of contamination values were in the low and moderate categories. Pollution load index was increased at minor, but was not influenced at Spring Hill by poultry litter application. All the pollution load index values were in the moderate polluted category. Overall, all these results suggest long-term poultry litter application does not cause severe soil contamination by heavy metals. Application of poultry litter significantly increased the zinc content in corn and soybean grains by 8 to 17% at both locations. However, the concentrations of the other heavy metals in crop grains were not influenced by poultry litter application. These are the conclusions from this study. Long-term poultry litter application did not cause arsenic, cadmium, chromium, or lead accumulation in the soil profile of corn and soybean grains under Tennessee production conditions. Non-term poultry litter application enhanced zinc contents in surface soil and in corn and soybean grains as well, which is beneficial for animal and human health when crop grains are used is feed and food. Contents of total and available copper were increased in the surface soil due to long-term pollinator application. But zinc contents in corn and soybean grains were not increased. Overall, annual pollinator application rate is 4.4 tons per hectare based on crop lighting requirement is generally safe for human and animal health and the environment under Tennessee production systems. With that, thank you very much. Goodbye.